All right, so we need to do the rational root test. And to do the rational root test, we need to identify our biggest negative and smallest positive. Our biggest negative is our last number, which happens to already be negative. And then our smallest positive is 1 divided by this number, which is also 1. So the smallest positive is just going to be plain 1. So now at this point, what I'm going to do is I'm typing my function into my calculator. And then I'm going to use my table to figure out where my zeros are. So let's go to the calculator. I'm going to y equals, and I need to type in my problem here. So x to the 4th. Make sure you arrow down out of the exponent. Plus 7x cubed, arrow down, plus 4x squared, minus 36x, minus 16. So that's always good to get that done first. Now I go to second window. I'm changing my table start value to negative 16. And then my delta table is going to stay at 1. Now when I go to my table, I'm starting at negative 16. I can stop looking at positive 16. So I'm going to go to my table, and I'm looking for the blue numbers. I want my rational roots will be the ones that have a 0 in the blue column. So I'm going to just keep arrowing down. Okay, I see 1 at negative 4. And then remember, I have to keep looking until I go, oh, here's another one at positive 2. So I have negative 4 and positive 2. And then I have to keep looking all the way to positive 16. Okay, so I have 2 rational zeros. I'm going to go back to them really quick so you can see them both. So at negative 4 and positive 2, those are my rational roots. So I'm going to go back to my problem here, and I'm going to write down x equals negative 4, x equals positive 2. So I have half of my solutions right there. So the next thing we're going to do is synthetic division. And I'm going to do synthetic division twice, and it does not matter which number you start with. I'm going to start with negative 4 because I wrote it first. So I'm going to write down all my my coefficients. So I would have 1, 7, 4, negative 36, and negative 16. And I'm going to do synthetic division all the way through. And friendly reminder, we should get a 0 here. If we don't, we made a mistake. So I'm bringing down the 1. Negative 4 times 1 is negative 4. If you add down, that would be 3. Negative 4 times 3 is negative 12. If you add down, you'd have negative 8. Negative 4 times negative 8 is 32. If you add down, you would get negative 4. And then negative 4 times negative 4 is positive 16. And when you add those, you get 0. So now I'm going to do synthetic division again. And instead of using my original numbers, I'm now going to use this 1, 3, negative 8, and negative 4. So what I like to do is just draw another synthetic division bar right underneath it. I am now not using this 0. It's gone. I'm only using these 4 numbers here. And now I'm going to put 2 on the outside. So same process. Bring down the 1. 2 times 1 is 2. If I add, I get 5. 2 times 5 is 10. If I add down, I get 2. 2 times 2 is 4. And if I add down, I get 0. And again, you need to get 0 here, otherwise something went wrong. So now we can do quadratic formula. So this is my A, B, and C. I'm going to write down quadratic formula up here. And I'm going to plug in A, B, and C into the proper places in this formula. So I would have negative 5 plus or minus 5 squared minus 4 times A times C. And that's going to be over 2 times A, which is 1. So I have negative 5 plus or minus. I'm going to figure out what this radical is. So I'm going to take everything I'm highlighting in yellow and put it in my calculator and figure out what this is. So I'm actually going to show you on my calculator what I'm going to do. So I'm going to go back to the calculator screen. I'm putting in 5 squared minus 4 times 1 times 2. So I put in everything under the radical. I did not put in the radical. And I press enter and I get 17. So 17 is what goes under the radical here. 17 is a prime number, so I can't do a factor tree. I can't simplify any further. So that means we are completely done. That's the green answer represents 2 solutions, and then there are 2 purple solutions for a grand total of 4. which makes sense because we had x to the fourth as our highest exponent.